Good evening, everyone. So, welcome to my YouTube channel, Maths Avatarm. So, today we are going to see problem set third on uniform convergence of function. It contains some important questions. Till now, if you have not subscribed my YouTube channel, kindly subscribe my YouTube channel for latest news. Okay. So, let's start today's session now. So, what is first question? First question is really very important. I have especially selected for you. Okay. So what is this? Fnx is a function defined, each fn is defined on non-negative real numbers, and f1 is under root x function. Fnx is equal to under root x plus f1, that is defined inductively. Then first option is fn is pointwise convergent on closed interval 0 infinity. Fn is uniformly convergent on AB where A is greater than 0 and is less than B. Third option is Fn is not uniformly convergent on 0B, B greater than 0. All the options are correct. Okay. So this question is a little bit tricky. So you see that f1x is under root x function. Okay. F2 is under root x plus under root x. Now you see that this is greater. So my aim that I will for fix x, I will show fnx is increasing function and I will show that it is bounded above. Then it will be pointwise convergent for each x. Okay. That is the aim. And later I will show that this is actually the pointwise limit is actually uniform limit. Okay. So what is that? To show that it is monotonically increasing, you fix x belongs to closed interval AB. Okay. Where A is and B satisfied with. Now define hxt is equal to under root x plus t. Let's say it is gt. Now you take derivative g dash t is equal to 1 upon under root x plus t because x is this. Now you see that this is non-negative for all t belongs to closed interval AB. Okay. It means g is increasing function. Increasing function. Okay. If it is increasing function, so I know that under root x, I am taking t is equal to 0, but 0 is less than under root x. So x, this is greater. Okay. Now again, root, we have shown that this is increasing function. Then this will be greater. Like this, it will follow. And okay. So what is this? This is f1x. And this is f2x. And this is f3x. And so on. And in between, fnx will be. Okay. So this implies fnx is monotonically increasing. Okay. Now I need a bound. If it is monotonically increasing and a relation is already given, so I am using some idea here. What relation is given? Relation is given in fn, and the relation is given fn plus 1 is under root x plus fn x. So x is there. So for fixed x, it is monotonically. Let the limit exist. Then what will happen? You taking n tending to infinity, it will be L and it will be also L. Okay. Now you solve it for L. What you will get by the Sridharacharya formula? You will get after taking square both this side, you will get L square minus L minus X. You will get L is equal to 1 plus minus 1 plus 4x by 2. But because function is non-negative, so limit cannot be negative. So the possibility is that L is 1 plus under root 4x plus 1 by 2. Okay, because limit is each fnx is non-negative. So limit cannot be negative. So this is okay. You either write 1 plus 4x or 4x plus 1, same thing. Okay. So this is the guess. It means function is monotonically increasing. Our aim to show that we will show that f and x is less than fx. Okay, so I am letting where, so let fx is equal to 1 plus under root 1 plus 4x by 2. So my aim is that fnx is fx less than equal to fx for all and belongs to n. Okay, now we will prove it by mathematical induction. You check that for n is equal to 1, what we have, f1x is under root x, that is less than 1 plus under root 4, 1 plus 4x by 2. You can check this happen because this is, okay, this happens. This is true. Okay, because after taking 4x it will be and 1 plus 4x, so it is greater, that is my fx. So for, let's say it is equation number 1, for n is equal to 1, the equation 1 is true. Now consider 1 is true for n is equal to k. Okay, then what does it mean? If 1 is true for n is equal to k, then what does it mean? It means fkx is less than fx. Okay, let's say equation number 2. Now we will prove we will show that 1 is true for n is equal to k plus 1. Okay, so how I will prove? Next, what is f square x minus f k plus 1 square? That is, what is this? This is 1 plus 4x upon 2 ka square, and that is x plus f k x, that is square. Okay, so solve it. 1 plus 1 plus 4x, that is 2, 1 plus 4x upon 4 minus x plus f k x. You solve it, you will, what you will get? 2 plus 4x plus 2, 1 plus 4x minus 4x minus 4 f kx upon 4. So 4x cancel out. Okay, now you separate them, what you will get? 2 will be common, 1 plus under root 1 plus 4x upon 4 minus 4 f kx upon 4, that is cancel. 2, 1 plus 4x by 2 minus f kx. So what is this? What is this? This is fx minus f kx, that is greater than 0. But what is this? Fx is f k plus equal to this. This is, okay, it means f k plus 1 x is less than f x. So it means by mathematical induction method, by mathematical induction method, fnx is increasing and bounded above by fx. So by monotone convergence theorem, so fn converging to fx is equal to fx. Okay, now you see that fnx monotonically increasing. Okay, each fnx is continuous, fx is also continuous on AB. Fnx is continuous, fx is continuous by Dini's theorem. Fn theorem, f converges to f uniformly on closed interval AB. But now you see that if we change the interval AB to, now if we change the interval AB to closed interval, if we change the interval, you take this interval 0b. Now what is fn0? Fn0 is 0 for each 0. Okay, and that is tending to f0. Zero sequence tends to zero sequence, sorry, zero limit, and that is f0. But what is fx? It is 1 plus 4x by 2. So what is limit of fx from right? That is 1 by 2. It means that is not equal to f0. It means f is not continuous. Each fn is continuous on 0 to b close interval, 0 to b close interval, and f is not continuous. F is not continuous on close interval 0 to b. What does it mean? Fn cannot converge uniformly to close interval 0b. Okay, it means Fn do not converge. It means Fn do not converge to F uniformly on close interval 0b. Okay, so which option is correct? Fn is pointwise convergent. Yes, it is pointwise convergent. First option is correct. Second option, Fn is uniformly convergent on this. Yes, it is correct. Second option is also correct. Third option is Fn is not uniformly convergent on. Yes, this is also correct. All the three first options are correct. It means fourth option is all the options are correct. Yes, this is correct now because it includes all three first three options and that are all correct. Okay. So now move to question number second. Let I be an interval containing 0 and x is equal to 1 plus nx square be defined. Okay. Then Fn, first option is Fn and its derivative are uniformly convergent on I. Second option is Fn is uniformly convergent on I, but derivative is not uniformly convergent. Third option is Fn is uniformly convergent, but derivative is not. Third option is Fn is not uniformly convergent, but derivative is uniformly convergent. Both Fn and Fn derivative are uniformly convergent. Okay. Okay. Now see that Fnx is equal to x plus 1 plus nx square. So I can write this function n under root nx upon 1 plus under root nx square upon 1 upon under root. You see that this function is monotonically increasing for each, okay, each nx. But that is, but this is bounded by which quantity? 1 by 2. This function is bounded by 1 by 2. It means its absolute value is bounded by, because this function is bounded by 1 by 2. Okay, 1 upon under root 1 upon 2. Okay. Okay. So what does it mean? It means that is, but this tends to 0 as n tending to infinity and do not depends on n. It means Fn converging to F uniformly. Okay. Fn converging to F uniformly. Now what is derivative function? What is derivative function? Derivative function Fn is equal to 1 x upon 1 plus nx square. What is derivative? Fn dash x is equal to 1 plus nx square का square. It's x derivative done 1 plus nx square. X its derivative 2nx. Okay. So what is that? This is 1 plus nx square minus 2nx square. 1 plus nx square by, so this implies Fn dash x is equal to 1 minus nx square. Okay. And that is 1 plus nx square. Okay. Now see that what is this? What is fn0? Fn dash 0 is 1. Okay, and it will converge to 1. So so its derivative limits, let's say g, point-wise limit is g. So g0 is this. Now what about if x is non-zero? If x is non-zero, then what is fn dash x? 1 minus n x square. You can check that this tends to g0. It means g x is 0. This limit tends to 0. You can check. Okay. So this is gx. It means what is gx function? Gx function is 1 if x is 0, and it is 0 if x is in this. So g is not continuous function at 0, not continuous, but each fn dash is continuous. Okay, continuous. Fn dash is continuous on closed interval 0, 1. G is not continuous. Fn dash is continuous. So whether fn dash can converge to G? No, because uniform limit is always continuous. So G cannot, fn dash cannot converge to G uniformly. So which option is correct? Fn is uniformly convergent, but derivative function is not uniformly convergent. So which option is correct? Let's see. Okay, so first option is not correct. Second option, Fn is uniformly convergent, but derivative is not uniformly convergent. So second option is correct. Third option is not correct because Fn is uniform. Both are not uniformly convergent. That is also not correct because Fn is uniformly convergent. Okay. Now next move to question number 3. Let Fn be an interval containing 0 and Fnx is this. Okay. Then both Fn and Fn dash are uniformly convergent. Second option is Fn is uniformly convergent. Okay. Fn is uniformly convergent, but Fn dash is not uniformly convergent. Third option is Fn is not uniformly convergent, but Fn derivative is uniformly convergent. Fourth option is Fn and derivative both are not uniformly convergent. Okay. Now you see that we have already seen this example that Fnx is not uniformly convergent here because we have done this question. Now derivative we have not checked, but we will check. Okay. Okay. So what is Fnx is nx 1 plus n square x square. Now interval contains 0. It means for n is equal to intervals contains 0. What does it mean? Interval contains 0. What does it mean? So you see that in previous question, first I'm doing the interval containing 0. Okay. Okay. So I have taken closed interval 0, 1, but you can think some because if suppose I contains 0. What does it mean? There will exist b greater than 0. Closed interval b or b will contain in I. So I can take b here. Okay. No problem. G is not continuous on closed interval 0b, but Fn is continuous on closed 0b. So it cannot be converged uniformly. Okay. So that argument is correct. I have forgotten that is I interval containing 0. No problem. Still option number B is correct. Okay. Now move to third question. Okay. We have already done this question So now see that pointwise limit is 0 for each x. Okay. Now, but when fn x minus f0, that is fn x, that is nx upon 1 plus n square x square. If I will take xn is equal to, because 0 is contained in I, there exists capital N belongs to N such that xn is equal to 1 upon n is contained in I for each n belongs to n. Now I will take this f n xn will be what? It will be 1 upon 1 plus 2, that is 1 by 2 for all n greater. So it cannot be make less. If I take epsilon is equal to 1 by 3, that will not happen. This implies fn x is not less than, strictly less than epsilon. This implies fn do not converge to f uniformly. So fn do not converge f uniformly. So fn is not uniformly convergent. And now what about its derivative? Derivative function is fn x is given nx upon 1 plus n square x square. So derivative is fn dash is equal to, you keep n outside, n square x square. What is this? 1 plus n square x square. Okay. X into, what will its derivative? 2n square x fn dash x to n. What is this? After solving, you will get 1 minus n square x square. Okay. 1 plus n square x square. Now, what is fn dash 0? This is n, and that tends to infinity, as n tending to infinity. It means limit does not, pointwise limit does not exist. It means fn dash at 0 is not convergent. If fn's are not convergent at some point, it means pointwise limit does not exist. It means fn dash does not converge uniformly. Okay. So what we conclude? This implies fn and fn dash both are not uniformly convergent. Okay. Uniformly convergent. So which option is correct? Both are not uniformly convergent. Which option is correct? Fourth option is correct. Okay. First option is not correct. Second option is not correct. Third option is not. Fourth option is correct because both are not uniformly convergent. Move to fourth question. Okay. Now, this is given that this is uniformly convergent. Okay. Now, I will use here a Bell test. B and X, A and X. Okay. A Bell test I will use. What is B and X here? B and X, I am taking this n x to the power n 1 minus x 1 plus x to the power n. Okay. Now, so okay. Now, first of all, whether this is monotonically increasing or not, you fix x. For fixed x, B and X is what? N x to the power n 1 plus x to the power n. If x is fixed, this function is monotonically increasing in n. This is monotonically increasing in n. And this is fixed. It will not affect anything. This is fixed. And this is n. N is increasing function. So it means what? Okay. And this is non-negative also. This is non-negative also because interval is defined close interval 0, 1. Okay. If you multiply two non-negative monotonically increasing functions, it is monotonically increasing functions. Okay. Because it is also non-negative. So actually this is monotonically increasing, this is monotonically increasing, both are positive, and this is constant function because x is fixed, that is also non-negative. This is whole is monotonically increasing. So this implies b and x is monotonically increasing. Now you see that what is b and x? B and x is this n x to the power n 1 minus x 1 plus x to the power n. Okay, if I can show that n x and if I can show that numerator is uniformly bounded, then automatically this will be whole b and x will be bounded because the numerator is greater than equal to 1. I will skip x to the power n and then it will be greater, and this quantity is uniformly bounded, then whole b and x will be bounded. Okay, so my aim to, let's say gx is your gx is gxn is this, gxn is g comma xn is n x to the power n 1 minus. I will show that g and x is uniformly bounded. So how I will show? I will show that gxn is uniformly bounded. Okay. So what is the derivative? So I am fix n. Let's say it's g and x. It is g and x. Fix x. You fix x. You fix x. G and x is, what is the derivative of g? dg and x upon dgx. You take x and x to the power n minus 1 1 minus x minus x to the power n. Okay. So what is this? This is n x to the power n minus 1, that is n x n minus x n. So what is this? N. Okay. So x to the power n minus 1 you can take. This is n plus 1 x. When it will be 0? When it will be 0, derivative will be 0 because we want to find maximum point. Okay. So this is x is equal to n upon n plus 1. 0 we will not take because g and x is non-negative. At 0 it is 0, at 1 it is 0. So maximum will exist in between. Okay, we know. So what is g and x at this point? Maximum will exist at this point. What is that? X to the power n. So n, put this value. So put this value. This value is n upon 1 plus to the power n 1 minus n plus 1. After solving you get n plus 1 upon n plus 1 to the power n. And after solving it you will get n plus 1. Okay. So what you are getting? You are getting n plus 1 to the power n plus 1, that is 1 upon 1 plus 1 to the power n की power n plus 1. So maximum value is this. It means g and x is less than equal to 1 upon 1 plus 1 to the power n plus 1 for all n greater than equal to 1 and x belongs to close interval 0. Okay. Now what about this function b and x? B and x is equal to n x to the power n 1 minus x to the power n, 1 plus x to the power n. So this is n x to the power n, 1 minus x, 1 plus. So I can remove, I can take 0 here, so it will be increased. Okay, I will, so it is less than this. But this is gx, what this is gnx. Gnx is non-negative, so I can skip the mod, but this is less than 1 upon 1 plus 1 upon n to the power n plus 1. So what does it mean? Bn x is equal to 1 upon n plus 1. Okay, but this is a convergent sequence. Since 1 plus 1 upon n to the power n plus 1 limit is n tending to, it is 1 upon, sorry, 1, it is 1 upon e. So it is bounded. So this is, this implies this sequence 1 upon n plus 1 is bounded. So implies करता है there exists m greater than 0 such that this is less than equal to m, this sequence. It means bn x is less than k for all n and x belongs to x, okay, belongs to 0 1. It means bnx is uniformly bounded. It means bnx is uniformly bounded. Now bnx is monotonically increasing and uniformly bounded, and summation a n series is uniformly convergent by Abel's test. Abel's test implies this series 1 to infinity bnx anx that is equal to summation n goes to 1 to infinity and x to the power n 1 minus x upon 1 plus x to the power n anx is uniformly convergent. Okay, this series is uniformly convergent. Given series is uniformly convergent. So which option is correct? Option number is, which option is correct? It is pointwise convert, not pointwise convergent. This is not correct. Is it pointwise convergent but not uniformly? This is not correct. Uniformly convergent. Yes, it is correct. So option number C is correct. Now question number 5. Last question we are moving. Okay. Now an is a real sequence and r is greater than 0 and converges for all x belongs to r such that this happens. Then what about this? A n x to the power n. Okay. Now I can write this series a n x upon r to the power n, okay, the power n. Okay. Now I can write like that, n is equal to 1 to infinity x upon r to the power n a n r to the power. Sorry, I can write small r here. So write it below, just below. What is this? So I can write a n an x upon r to the power n into r to the power n. Now collect this n is equal to 1 to infinity. X upon r you keep one side and an r to the power n one side. Okay. Now what is my bnx here? Bnx is x upon r to the power n. And what is this series? It is given that in question it is given that series is convergent for x. You can take r also. I'm taking x is equal to r, then this what will be this series? I'm taking x is equal to r. So I'm writing in a proper language. This series is convergent. How? Because this do not involve any x, so it is uniform. This implies it is uniformly convergent. How it is convergent, then how it is uniformly convergent? We need to show that it is convergent. And because it do not involve x, so automatically it will be uniform convergent. It is given in question. It is given that in question that a and x to the power n is convergent if x is satisfy this. So I'm taking x is equal to r. It means n goes to 1 to infinity. A n r to the power n is convergent. If this is convergent and it do not involve x, so this is it is uniformly convergent. And what about b and x? You fix x, then you fix x, then okay. Then what about x upon r? Its absolute value is less than equal to okay. Sorry, there is a problem in this question. 1 minute. Yeah, there is a problem in this question. X belongs to R such that I am to correct it. We need to take X such that X is greater than equal to 0 and less than R. It means this condition. X is greater than equal to 0 and less than equal to R. Okay, this condition is not correct. I am correcting it. Okay, this is given. So here what I will do, still the series is uniformly convergent because in question it is given this. Okay. So sorry, x less than r. So I can take x is equal to r. Okay, it will work. Now for fixed x, my x, what is my x upon r? X upon r is in this range. Okay. So it means if I take x upon r equal to 1, then b and x 1 upon it is constant function 1 that is monotonically increasing. Okay. And if I take x 0 or less than 1, then because you take x any number in between 0 1 and take powers will decrease it. Okay, so it means this function is monotone, is monotonically decreasing. If you take any x, in this range, okay, then x upon r will be in this range. So if you put x upon r equal to 1, then it will be 1. So it is constant function is also monotonically decreasing. If you take in between, its power will make it decrease. So it is monotonically decreasing. Now this series is uniformly convergent by Abel test. By Abel's test, the series summation n goes to 1 to infinity b and x, a and x is uniformly convergent. Uniformly convergent. And what is this? What is this equal to? Summation n goes to, what is this? A what is this? This is x upon r to the power n. X upon r to the power n. What is this? A n x, a n r to the power n. So what is this? X to the power n, r to the power n, a n r to the power n. This is cancel out. So this is n is equal to 1 to n, a n r to the power n. It means this is uniformly convergent because this series uniformly convergent. This is equal to this, but this is finally turn out to be this. This is uniformly convergent. Okay. So which option is correct? Okay. So which option is correct? Sorry, 1 to the power, not r in last. I have miscorrect. This is x actually. This is x. This is x. So this series is uniformly convergent. Okay. So which option is correct? So it's uniformly convergent on closed 0R. First option is correct. Second option is not correct because series converges uniformly. So it will converge pointwise. Third option is not correct because it is uniformly convergent. It's pointwise convergent but not uniformly. This is also not correct. So first option is correct. Okay. So we have done all the questions. If you have any problem or issue related to this session, you can comment me on your YouTube channel. Still, you have no, if you have not still subscribe my YouTube channel, kindly subscribe it. So like, comment, share, and subscribe my YouTube channel. And if you feel any problem, comment me on my YouTube channel. So thank you very much for today's session. Thank you very much. We will see you in next session. Thank you very much.